How many positive integers x and y satisfy the 2x plus y less than equal to 40? So we have an algebraic inequality here and we need to find out the total positive integer solutions that satisfy it. So to answer any such question, I basically look at the pattern of the solutions that is acceptable. So let me quickly find it out. 2x plus y should be less than 40. What I can do is I'm just starting with the value of x first, because the value of x that I can take here will be very limited. I can take values of x only from they are positive integers, so I can start from 1 and can go up to a maximum 19, because the 20 will make this y 0, and anyway this will not be less than 40. So I understand that the value of x has to vary from x till 19 and both are acceptable. So let's start the first thing. If I take the x is equal to 1, now in that case the value of y, because this part is 2, then y has to be less than 38. That means the value of y can be anything from 1 till 37 actually. 38 won't be acceptable, so that gives us clearly 37 solutions to the first equation, right? Now similarly, let's substitute the value of x is equal to 2. In that case, so in the first case we had how many solutions? 37 solutions, x equal to 1, so the value of y can go up to 37. For x equal to 2, the value of y can once again start from 1, but now because this part is 4, so the value of y has to be less than 30, less than 4, because less than 36. Less than 36, that means there are 35 possible values that this can have, so there are 35 solutions in that case. Let me quickly check if everything is all right. If x is chosen as 2, then the value of y, 2x plus y, this becomes 4, so this has to be less than 36, and y is less than 36, so y can go from 1 to 35. The question says that y is a multiple of x as well. Okay, so that's last condition that I will quickly figure out how many possible values, possible solutions are we getting in each one of these cases. Let me quickly figure out the solutions first. If x is equal to 3, then the value of y can vary from 1, and 3 into 2 is 6, and so this is 34, has to be less than 34, so we can go up to 33. So here we have 33 solutions, and I'm just going to do that quickly. If x is equal to 4, then the value of y can go up from 1 till this becomes 8, so this is 32, so we can go up to 31, so we have 31 solutions. Now you can see that there is some pattern. Every time we are decreasing this by 2, that means if we take the value of x equal to 5, the value of y can go up to 29, so there will be 29 solutions. Now the question is, so this will continue to go on, but at the same time we also have to quickly figure out that how many solutions are acceptable, because we have to satisfy this condition as well. If y is a multiple of x, so here all the 37 solutions are acceptable because all of them are multiples of 1, which is the value of x. So every y is a multiple of x. Now in this case we can choose only the even values, and out of these 35 solutions there are 17 even values and 18 odd values, because it is starting from odd and ending at odd. So there are only 17 acceptable solutions. Now let's look at this. From 1 to 33 there are 11 solutions that are multiples of 3. From 1 to 31 there are 7 solutions of which are multiples of 4, right? From 1 to 31 it is 7 multiples. In this particular case the multiples of 5 will be 5, because from 1 to 29 we have only 5 multiples of 5. Let us see if there is any pattern. 37 and then 17 and then 11, so here the decrease of 20, then there is a decrease of 6, then there is a decrease of 4, and then there is a decrease of 2. So now it's changing. No such observed pattern can be seen here as of now. Let me quickly see. At x equal to 6, the value of y can change from 1 to this is 6 into 2, 12. So 12 subtracted from 40 leaves us 28, so that can go up to 27. That means we have 27 solutions. Then we have 25, because it is continuing to decrease by 2, then 25 solutions, and then we have 23 solutions, and then we have 21 solutions, and then we will have 19 solutions, and then we will have 17 solutions, etc. So let's quickly see how many are acceptable here. So out of these 27, the multiples of 6 will be 4. So 4 solutions, and multiples of 7, because this will be at x equal to 7. So we have 3 solutions here. We have multiples of 8, 2 solutions, multiple of 9, 2 solutions, multiple of 10, 1 solution. So after this we will continue to go with 1 solution, because after that every set will have only one multiple, because there is only one multiple of 10 from 1 to 19, there is only one multiple of 11 from 1 to 17. So this way it will continue to go on. Now we have gone here till x equal to 10, right? And we have to continue to go till x equals to now the values of x are continuously increasing. This is the possible case when we have x equal to 11. We'll have to quickly figure out that how many such solutions are we getting. So let me quickly bring it on the next page. We still have, let me just quickly remove it. We have 2x plus y less than 40, and x equal to 11. We have seen at x equal to 11 there was 11 to 2 22, so this was 17, right? So the value of y was varying from 1 to 17. At x equal to 12, the values of y will be varying from 1 to 15. At x equal to 13, the values of y will vary from 1 to 13. So there is only one solution, so we can go only till this step. One solution in each case if y is a multiple of x. So 3 solutions on this screen, and we have all the acceptable solutions so far on this screen itself. And how many solutions do we have? At x equal to 10, one solution. At x equal to 11, again one solution. And on the next screen that we saw, we had x equal to 11 onwards. So let's quickly add here till 10. So till 10 and plus 3 more solutions which are on the next screen. So the total number of solutions will be 37 plus 17 plus 11 plus 7 plus 5 plus 4 plus 3 plus 2 plus once again 2 plus 1 plus 3 solutions. And if we keep adding them, let's quickly see what is a unit digit, because that can determine the answer. 7 and 7 14, 4 plus 1 is 5, and 7 2 plus 5 7 plus 4 1 plus 3 4 5 6 7 8 9 10 11 12. So we will have total of 92 solutions, and therefore the answer to this question is option C. So it's a very lengthy question because there is no particular pattern that is emerging in the number of solutions, but we'll have to do these 10 plus 3 13 steps to answer this question. I hope that makes sense. Such a question, I don't think that can come in GMAT, but it's just a good exercise to do beforehand. I hope you enjoyed the learning. Thank you so much.